Hello everyone, we will start the session in 2 minutes. We are receiving more participants at this point of time. All right, Tawfiq, you can start the session.
I'm audible?
Yes, go ahead.
Hi and good evening to everyone. It's my pleasure to introduce our speaker for today's session. We have with us Daksh Bhagwani, a passionate cybersecurity researcher and bug bounty hunter. With a strong foundation in security research, he has continuously contributed to bug bounty community, has been continuously exploring emerging area in cybersecurity. Currently, his research focus on automotive security, where he is working on understanding and improving security mechanisms that protect next generation vehicles. What makes it even more exciting is interest in integrating quantum technology into automotive security, aiming to future-proof vehicles against emerging threats in quantum era. His work effective not only technical expertise but also forward-thinking mindset towards evolving challenging cybersecurity. Please join me to welcoming Daksh Bhavani for today's session, Automotive Security and Quantum Threats. Daksh, session is yours.
Thank you so much, Tawfiq. I hope I am audible.
Yes, you are.
Yeah.
All right. A quick mic check is required always. All right. Hello, everyone. Good evening. Welcome to the session, ladies and gentlemen. So, I think before we move on, I would request every one of you to be really open about what we are going to look today, as well as I want, I would really appreciate, if you guys will be interactive all along what the things are and small questions which I will be asking in the between, right? So before my introduction, I think let's move forward to what we are looking to. All right. So now I was getting a lot of critics on how automotive security and quantum threat, quantum technologies or quantum cryptography, how is it related, right? So yeah, in this particular session, we are going to look forward with not just a simple explanation on how the automotive security works, but what factors can lead mainly to affect the cryptographical part, right? So yeah, your car has a network and it can be easily hacked. So ladies and gentlemen, myself Daksh Bhagwani, and I am a bug hunter as well as I'm researching on automotive security and trying to protect some part of it with the upcoming quantum threats. Well, currently I have been a speaker and leading to the innovation side, and I'm really excited to conduct this session on Owasp stage. Really excited to see how beautifully it goes, what questions you guys have after the session. So I think it's a good time to begin the session. All right. Before moving forward, I want to clear out that I have divided this particular session in three parts. What are we looking? Why are we looking into it? And how we can actually improve it. right? Along with it, we are going to see bits and pieces of simulations, which will help you understand what threats can it lead to, right? Yeah, what are we talking about? Okay, vehicle, car, bus, truck. Vehicle can be anything. Even a two-wheeler vehicle is a two-wheeler motorcycle is also a vehicle, right? But in today's generation, we cannot say a car simply as four wheels running with a steering wheel, right? It's connected with the internet. It has all-time internet access. It has a lot of functionalities, ABS, airbags, infotainment systems, whatnot, right? So before moving forward and understanding, what things are we going to look forward, just a small poll. How many of you are actually professionals which are working under automotive security, and how many of you are, students? I would just like to know a quick check. You can give your inputs in the chat box, right? Beautiful. Okay. Majority of crowd is student. Okay. All right. That's really beautiful. Thank you so much for input, guys. Okay. So you guys might not know what's really working inside a car. No worries. I'm here. I'll be explaining how the things are working in a very smooth way. Right. So now, first thing, don't scare after seeing this architecture. You're going to see in depth what are the small parts and what are the small components working in the car. Right. So this is a modern vehicle architecture. Now, as I was saying, nowadays the vehicles, this generation vehicles are not just four wheels which are controlled by a steering wheel. They contains thousands of sensors, 100 plus ECUs containing what not functionalities. Even when the airbag bursts in case of any mishappening or accident, it is working with because of an ECU. Even when you are pedaling so that your car accelerates, it is also because of an ECU. When you turn on your engine, what is happening? The ECUs are responding to turn on the engine, and that leads to start your car, right? So we can say that it's not just a box, but a box which is connected to internet, which has a lot of components running together so that it can provide a beautiful experience for you to drive on the road, right? Right. Now, moving on the most important part, how is it connected to the internet? I clearly just stated that okay, it is connected to the internet. But how? Right. So this is an important part where actually we have to understand that okay, let's take an example. All of you guys might have seen fancy displays in cars. Let's take the latest Mahindra B60. All right. So you have seen a lot big displays where you can control your music, you can control YouTube, you can even see GPS, everything. Right. How's it happening? Is it some magic happening? No. Are you providing a personal hotspot to the display? No. Right. So this works because of an eSIM which is being installed in the vehicle so that it provides 24 into 7. Obviously, when you turn on the car, it provides internet access to you so that you can enjoy all the functionalities which are there. As you can see, a small image in the left corner, Spotify, GPS, Netflix. I'm not very sure if many of the displays do provide. YouTube is one of it, right? So now all of these are connected together and provide few different functionalities. So it's not that these things work very simply. 70 million, thousands of millions of lines of codes are working behind it to make that possible, right? Now, I want to ask one simple question. You guys, how many of you guys actually update your phone while any security patch is there or any bug or error is there? The mobile organizations or mobile service centers provide updates. How many of you actually honestly update it on time? Okay, great. Uh-huh. On the same day. Okay, all right, that's great. Yeah. So now for half of the crowd which does not even care about actually updating it, what if there was a major vulnerability which was being reported on your phone? Let's take an example of Samsung M14. All right, a simple example, right? So let's tell that that particular phone had a major vulnerability or a major bug which has to be fixed, or it can be easily, exploited by any kind of attacker, right? But during the OTA update, when the update was being sent to your phone or other devices of same serial number or the same model number, the OTA update was interrupted because of an attacker. So now, as the update was not accomplished or not completed perfectly, it means that your mobile device remains vulnerable to that particular bug or vulnerability. Am I right or not? Right? So yeah, similar things do work with vehicles as well. Vehicles do have major and minor patches, fixes, etc., and whatnot, so that it can provide you a smooth drive on highways, roads, whatnot. Right? But what if these updates are not actually satisfied or not completed? It can lead a simple mistake or simple attack can lead your car to take over by the attacker. Just imagine you are driving your car at 120 in a beautiful highway, and out of sudden, your steering wheel is out of your control. The speed not in your control. Even the doors are getting locked or unlocked without your control. How scary it can be. You wouldn't want that kind of day. Obviously, you would panic, and it would be, I think, the last day you would travel in the car, right? Who knows? So these many things can lead a car under threat, right? All right, ladies and gentlemen, enough of scaring you with the attacker bullshit. But yeah, now let's actually see how your car can is an actual network running on road, right? An actual computer device which is running on four wheels on the road, right? So now I'm going to take you inside the car. Let's explore few components. Uh, there are mainly five components which we are actually looking into. First is telematics control unit, the CAN bus, which is the most important one. Second is third one is electronic control units, as I said, ECUs, gateway ECUs, which is also called as telematics box, and the last one is OTA firmware update. Right. Okay. So now telematics control unit. What is it? So the infotainment system, the display which you see in the car, which is connected to the internet, this thing is responsible for connecting internal and external networks, and hence it connects to the cloud. As simple as that. As you can see in the architecture design, this acts as a gateway to connect you to the cloud server or the network. As simple as that. Right? Now comes the CAN bus. Okay. CAN bus can be imagined as a simple Ethernet cable, but for vehicles. Not just a simple Ethernet, but just imagine as an Ethernet cable for vehicles, which connects two nodes or two endpoints. Now, what are the drawbacks of CAN bus? We're going to see ahead. Third one is electronic control unit. So, as I said, an example about how airbags, different functionalities like steering, braking, accelerating, engine, all of these are controlled because of an ECU, right? Right. Let's move forward. Next is the gateway ECU. Gateway ECU, as I said, it's a telematic box which controls all the logs, all the traffic happening in and out of the vehicle, whether it be any request from cloud, whether it be any request via the CAN bus to the gateway ECU or the T box, right? So controls all the external and internal networks. And last, is the OTA firmware update system. How it works is that we're going to see in the depth in few other slides. But yeah, let's understand the cloud server initiates some update or some fix to the patch, and with the help of all the cryptographical stuff, the patch is being transferred, and henceforth, after the verification, data integrity checks, the car gets updated with the firmware, right, which is being sent. All right, beautiful. Now what? Now comes CAN bus. As I told you, you can imagine CAN bus simply as an Ethernet cable for vehicles, but it is more than that. How? So first point which I would like to mention is that CAN bus transfers all the data unencrypted, which means it has its own way of communicating from one node to another, but it is in plain text, no encryption, right? So what it can lead that if an attacker can capture any CAN data, he or she can easily just see what is going inside the vehicle. All that what it would be not very easy for the attacker to check everything or every response. Reason being, as I told, key box or the telematics box or the gateway ECU, which controls each and every functionality, it collects and controls the traffic. So it contains logs of a lot of data, right? A lot of functionalities which are going on, temperature sensors, pressure sensors, speedometer, while you are accelerating each and every mile per hour as you increase it, right? It is getting logged. So that would be really noisy for an attacker to understand and decode it that what particular ID is leading to what particular functionality, right? So now what is an ID? Also called arbitration ID. Arbitration ID is unique for each and every functionality. Let's say I'm using 0x451 for unlocking or locking the door. Similarly, I'm using another arbitration ID as 0x651 for steering, right? And another one for speedometer. So there can be different IDs. And on the other hand, if you see this bytes, all of these are datas. So, taking an example, if I am going from 0 mile per hour to 100 mile per hour, so for each and every mile per hour which is getting increased for each and every second, what is my speed? It will have different data. Taking an example, it will log something as 00, and let's say my speed is 1 mile per hour. It will keep the byte as 01, 02, 03, and it keeps on increasing, right? It increments. Now, keeping these things, yeah, one more point, which is that there is a functionality called priority-based arbitration IDs. So henceforth, the lower IDs, which means 0x451, 0x651, and so on, are given the highest priority. All right. Okay. Now, let's move forward. Okay. Another fact which I would actually like to mention is that CAN bus does not know its destination. For example, I sent one message from tire ECU, right? It will be broadcasted to each and every ECU, and the arbitration ID will be checked, and then only it will be moved forward. I think I'm getting few questions. Do all cars have the same network architecture? All right. As we are in the architectural part, I would answer that. But yeah, I would like everyone to collect their great questions for the end. But yeah, see, cars do not have necessarily same network architecture, but the way they work is very same. It's very similar, right? All of them are connected to the cloud servers, their own private cloud servers, and via that cloud server, they are keep on updating the things, any messages, or any kind of information being sent to the car, right? All of that is being taken care of via that communication channel. We are going to see how it is. Yeah. So now, what can this canvas lead to? or CAN injection, which can be done by the attacker, what actions, harmful actions, can it lead to? It can lead the attacker to unlock the door. It can lead to disable the ABS or even your airbags. It can manipulate the speedometer, so which means that you will suddenly feel a thrust that, oh, it has started going from 10 miles per hour to 100 miles per hour without me even controlling it. Crazy, right? Next is triggering the dashboard alerts. So it can lead, to just provide some manipulative alerts on the dashboard, the car dashboard, which can include, let's say, headlights, right? It can trigger the headlights. It can trigger what other functionalities like speedometer dial. It can manipulate. So these things can be controlled by the attacker easily. Moving forward, now you're going to see something very connected with CAN, which is UDS. Okay, UDS is nothing but in simple words, is a diagnostic mode which helps to categorize that what are the services being provided. Okay, it's a standard protocol. How? So each and every service which will be provided, it has different UDS IDs. Example being, let's say 0x10. It is for diagnostic. So let's say the car is having some problem, engine problem or oil problem, anything, right? It will just trigger that particular information leading via canvas and provide that information to the dashboard, right? Similarly, for different things, like when we are switching from different ECU modes, if you guys know that different cars also have multiple modes like rain mode, sport mode, especially the higher end cars, and one is the eco mode, right? Especially eco mode is more overly exposed to the electric vehicle part, so that they can save the battery. Yeah, these all things are being controlled and tackled in a very simple information or diagnostic manner via UDS. All right. So now let's move forward to the most important part where we are focusing today. OTA. OTA stands for over the air, and what it controls is mostly the updation, the firmware update part, which is also known as the OTA updates. All right. Okay. Now, what is it used for? It can be used for bugs, just fixing the bugs, any upgrades, any safety patches, any vulnerability which a car might face, which is very rare. But what if some extraordinary hacker or an attacker tried to attack the car and or found some vulnerability which is very important to be fixed, right? So these OT updates are responsible to fix all of these things and make sure that user is not facing any kind of problems. But what if these updates are compromised? So if while the control center actually initiates the OT update, it is responsible that all these OT updates reach all the vehicle of the same model. Let's take an example, Mahindra B60, right? So if the control center is initiating the update, it should ensure that all the B60 receive these updates. And if they fail in doing that, there would be an emergency alert, which can lead further incident responses or certain backup updates. Right. Now, what things can lead this thing to fail? Right. The OT updates to fail. We are going to understand the compromise, like the OTA compromise situation. Okay. First, let's understand how OTA works. From the control center, uh, they initiate that, okay, this patch or this line of code is to be fixed. Okay. They initiated it, they signed it so that no one in the middle, a man in the middle or the attacker cannot, manipulate or put his own malicious input, and that is being delivered to the car or the vehicle. So that is being ensured via the signing authority. But what if the signing authority is being tempered? It can lead an attacker to, just temper the signing key, put its own signature, and try to pass on to the car. That would be really risky. Why? Because the car already has few master codes or master keys via which these signing keys are being verified. So the data integrity fails here, right? So now this becomes a very major issue if we see in terms of how the system will work. Because if the cars really fail to update these kind of patches, it can lead to further escalation of situation. Right. Okay. Perfect. Now we understood that what are the risks, how is it happening, and one more thing which I would actually like to mention, which is not here. You might wonder, you guys might wonder that okay, how is it connecting? How is it connecting to the cloud? As I said, infotainment systems are the main reason who are connected to the internet. And via the infotainment systems, it just passes the information to the gateway ECU, right? As we saw in the previous architectures, it just passes the information to the gateway ECU or the telematics box, and henceforth, whatever part of update is to be done in certain ECUs, this is the main component which tries to initiate it, right? Okay. So this is how the link works. Perfect. Now, why are we talking about? As I have clearly mentioned that, okay, what are the prior reasons? But let's now get and step into a bit depth that, okay, how, these things can affect the security. All right. Now, first, I want you guys to take a look on this clear architecture diagram. How is it working? Right. So as I explained that all the updates, it is being done via the internet as the car is connected to the internet or any cellular or Wi-Fi, right? It is being transferred to the telematics control unit, the gateway, and henceforth all the information is being transferred from CAN bus, right? Perfect. So, other than these things, we must also explore that what are other attack surfaces. Wi-Fi is one of them. Perfect. Cellular network is one of them. Okay. Bluetooth. Bluetooth devices are also there. One of the major drawback of any system being installed, which obviously cannot be removed, but can be secured, is that all these devices, some way or the other, can be attacked, right? Because there is a lot of attack surfaces via which the attacker can try to penetrate into the car and give the information or change the information according to his choices, right? Yeah, Bluetooth is one of the thing. Well, let's take an example of Bluetooth key fobs. You guys might have used key fobs to lock and unlock your car. Now, uh, the traditional key fobs are different, but the one which I'm talking are mobile as key. So how the mobile as key works is that when you are in the proximity of car, then only your mobile recognizes that okay, this car is under this 100 meter of range, and then only I'm allowed to control the car. Let's say if you are sitting somewhere in Goa and your car is somewhere in Chennai, right? You can definitely not try to control the car, right? If you are able to, that would be really risky because if some or the other way, your mobile was, you know, got into some wrong hands, the other person can easily access your car just sitting in Goa. How scary it is, right? So Bluetooth is one of it. Wi-Fi and cellular, as I told, connectivity, internet connection. Second is infotainment system, the main system which helps us to connect the user to connect with the car, right? Play music, do whatever you want. Also, if you might have observed, the recent EV cars also do have functionality to control more than these things. You can also change the temperature of car. You can also check whether everything is working perfectly in car. How is it happening? How the real-time data from the car is being transferred to that infotainment's small display. The main reason is canvas, right? Yeah, this is how the things work. And last but not the least, over the air updates as we saw. Yeah, you guys will hear OTA updates a lot of time in this session because this is the most important thing which we are focusing on. All right. Now, now we are stepping into a practical part, into the practical part of things. So, how the attacks can be initiated. So, one of the attack which I would actually like to mention is Mercedes-Benz S-class attack, which was happened in 2023, where an attacker or the researcher, I would mention researcher, he was able to easily just get into the car via API calls. He noticed that all the requests, whether it be locking, unlocking, or let's say just controlling the air conditioning of car, because nowadays the cars have the feature that you can turn on the AC. Let's say you have a meeting and you want the car to be cooled down before you enter the car. You have the functionality, right? You can control via your mobile phone. The car gets turned up and the AC is turned on automatically for a specific period of time. And while you enter, you get all the cool breeze. So yeah, all these functionalities were easily controllable via one API call. Isn't that a very risky thing? Because all the controls which are being controlled from your mobile phone device, a simple device, which is not even very big, a small 6.78-inch mobile phone, is risky, right? So moving forward, I'm going to explain you a live example of a simulation that how actually these things can work. These things can work. So as I have mentioned, a few vulnerabilities called IDOL and BOLA. You can basically understand it as that authorization level bugs, authorization and authentication level bugs, right? So because of the weak authentication and authorization, it leads to all these kind of problems in the vehicle, right? So if you wanna just imagine a scenario, someone was able to capture this API, some attacker in between. He was able to just forward the request via his burp suite, and you sitting in your office, your car just unlocked, and that attacker was happy to take a Mercedes-Benz S-Class. Congratulations, you have been hacked. Right. So this is what remote vehicle access can lead to. Perfect. So another attack, which is very old, obviously, but it had lead all this chain of how automotive security is in danger, right? The famous Jeep Cherokee hack. Okay. Before moving forward, if anyone aware about it and wanna share their insights, I would really, like to know about it. Anyone? You can just mention in the chat box. It would be really great. Yes, exactly. Yes, it was an RCE, full remote control access of the vehicle, just sitting at home, right? Yes, exactly. They connected and sniffed the canvas. Perfect. Beautiful answer. Right. So how this thing worked? How the attackers just sitting at home were able to control a vehicle which was running on highway via the internet. Yeah. So now I have explained a very simple workflow, which I will explain part by part. So now, as the vehicles are connected to the cloud servers, we all are aware about it. And as I told, the cloud servers are connected to the telematic control unit or the TCOs, which helps you to the infotainment system, which helps you to control the infotainment system. And all of the information which is being passed from the infotainment system is when as it goes through the gateway, and then the information is being spread out to all the specific ECUs, right? With the help of Canvas. So over here, the attackers were able to control the whole vehicle, including locking the car, unlocking the car, controlling the steering wheel, controlling the speed, everything. Just imagine, man, you guys are running 120 and these things happen. First and last day in the car, isn't it? Right. So now, the most interesting part of this was that they didn't even require physical access of the car to perform this attack. which is even more scarier, right? So I think a lot of theoretical stuff is being done, and it's time that we understand how the CAN stepping part actually works, right? How the CAN data looks like, what is arbitrary ID, how the virtual CAN network actually behaves like, right? So let's turn into the other display and see some practical use. All right. Okay. Just give me a second, guys. All right. I hope everyone is able to see my full screen now. Just a quick response in the chat box, please. All right. Perfect. Nice. So I have prepared few simulation for you guys to make you understand that how these things are working. So first, let's go and see the CAN traffic part. How is it working? Right. Okay. Sweet. So let's actually just clear this out. Start the dashboard. Oh wait, we'll have to first start our sweet box and then the dashboard. Perfect. All right. This is not how a car looks like. Obviously, this is very disappointing how the design is. But okay, let's not focus on the design, but the functionalities it provides. So right now I have three options, which is locking the door, and on. Right now, parallelly, I will be opening CAN with vCAN interface. All right. Before moving forward on analyzing it, so what I want you, I'll just increase the size of. So the virtual CAN interface is an interface which helps you to simulate the CAN network inside your PC or the laptop, right? So if you want to actually add this network, you will have to, type few commands, which is IP link. First, we'll add it. What will add? The name, which is vCAN 0, which is the name of the network we are adding. And what is it type of? It is type of vCAN 0 type, which is a virtual CAN network. So as I have already added, so it tells file exists. And then after we have added this virtual CAN network into our network manager, we have to turn it up, right? So how can we do it is IP link set vCAN 0 up. This will just make the network up. Perfect. Sweet. Now I'm just going to turn on the virtual CAN and let's see how the responses are working. All right, as you can see, it is beautifully working. I will just unlock door on and do some random functionality so that we have a lot of data to analyze it. Perfect. Now let's lock the car and keep it safely. Perfect. We have a lot of data. Nice. So as I mentioned that in the CAN frame, there were few boxes. Right? One was the arbitration ID, one was the data, right? So this is the arbitration ID, which is being presented in its own CAN format. Okay, how the CAN format, the CAN network actually transfer the data from one node to other. So this is the arbitration ID, which is used for either locking or unlocking the door in this situation. And as you can see some a few different arbitration ID, which is 651. So while I horn it, you can see the arbitration ID is different because the functionality is totally different. So that's how the things are working. Now comes to this part. All right. Now this is the data part where it tells the car some few specifications that what you have to perform. So over here, the 00 tells that okay, you don't have to unlock anything, right? Uh, yeah, as you can see, if I unlock the car, it gives this response where 00 presents that this is an unlock command. what you have to do is unlock all the four doors. Similarly, if I click on lock, so 01 and 01 provides that, okay, this response is for locking the door. And what are we going to lock is all the four doors. Similarly, our horn, few data packets are being transferred with the application ID 651. And what are we trying to do? Some byte of data along with some byte of data is being transferred. Let's not get into more technicalities. So this is how a basic CAN network works, but in more populated way and more noisy way in an actual way. Over here, we are just performing these three functionalities. But in a real car, there are a lot of sensors which are working together, which is pressure sensor, temperature sensor, how your engine is working, is it heated, everything, right? Everything is working together. And henceforth, if you just see this can dump will be flooded by multiple messages running together. So it becomes truly tough to understand that, okay, what ID is leading to what functionality. Right? But yeah, few analysis can help you out with the things because there are a lot of tools for CAN fuzzing, different things, right? Which can help you out to understand, okay, for this functionality, if I fuzz and try different data types, what response is it giving? So it's a hit and trial. All right, beautiful. Okay, now let's actually just close this server and move forward to our next thing. So now we have seen a small brief of how a CAN traffic looks like. Right, this is what we call sniffing a CAN traffic. Let's now move forward to API functionalities. That how actually these API functionalities can lead to attacks like IDOR or BOLA. Right. So for this as well, the good thing is that I have prepared a small simulation. Let's see. Okay, I think it's already running. What is this? Yep. I'll just start the server. Beautiful. So it's running on my local host. Okay. So this is like, let's take an example. This is a mobile application which you guys might use on a daily basis to log, unlock, or just perform any other functionality in your car. Right. So let's say I have my car Tesla. Yeah. Sure. Okay. So a Tesla and the ID for my car is 8391. All right. For the other user, I have the other card where the ID is 8392, which might not be very real in the real car scenario, but you can try to guess it, right? Who knows that the developer of this functionality did not actually care about how the attacks can lead to. But obviously, this is not very easy though. But there can be few patterns which you might see. Okay. So now what you're going to do is let's unlock doors. Okay. Command in unlock. Okay. Beautiful. Yeah. My door was unlocked. And what is happening? There's the timestamp. Who actually did it? Me. Daksh did it. What was the vehicle? This was the vehicle and this was the command. This is what the Fluid performed, right? From Cloud API, telematics, gateway, and ECU, then the via the canvas, then the ECU, right? So it tells doors are unlocked. Similarly, for other functionalities, you can just see that it just generates it. Okay, it's fine. But now I'm going to explain one thing via the code that I have two users over here. So the Tesla 8391, I am the owner of this car, whereas Tesla 8392, the other owner is Coco. Okay. And by default, the doors are locked. All right. And these are the authorization tokens. For the time being, I have kept it very simple so that it becomes easier for you to understand. Well, the authorization tokens can be in any format, whether it be base64 or anything, while they are transferring the data in JSON format, right? But yeah, let's take an example that my token is token Daksh and the other token is token Coco. So if I know these authorization tokens, I can easily control the functionalities of other car as well, right? So now what I can do is I've just kept all the commands good to go so that it becomes easier, right? Now, let's do one simple thing. Let's go to the terminal. Let's first clear these things. Now, I will give a curl command. What is it doing? Let's first understand it. Yeah. Okay. I hope. Yeah. Perfect. Hmm. So now, let's say this is the API request. What I got to know from intercepting the request from my mobile phone that this is the API request where the vehicle is following or performing any action, being it locking, unlocking, anything, right? And what it is doing is that the authorization token for each and every user, it is checking for authenticating the user, right? Next is the command which is being forwarded, it is in the JSON format. So over here, I have given the command as lock, right? Beautiful. So let's see, let's perform actually this thing and try to lock my car via this API request, where the bearer token is mine. Okay, wait. Okay, I think there is an issue. Yeah, yeah, beautiful. It executed it, right? What is it doing? It just uh, executed the command lock. Who executed it? It was executed by me. Okay. What is the status? It was executed. And what was the vehicle? There's the ID. What if using my authorization token, I try to actually control any other car where I know that what ID is it using, right? Let's say in the vehicles, I used 8392. This is the ID of the other car. And via the command request, I am performing to unlock it, right? That's what usually an attacker will do so that he can get into the car, right? Beautiful. Okay. Now what is happening? Now the vehicle has changed, obviously. The status was executed, but it was executed by me. Whereas the owner of the car was someone else. Who? Coco, right? And it says that yes, the command unlock has been executed successfully. All right, that's something to be tensed about. Like if we see in a simple scenario, in a general scenario, what will happen is that with the other person's token, he or she can easily unlock and perform the functionalities, which is truly normal, right? But what I'm trying to do is with my authorization token, I was able to control other car and it was successfully executing the command, right? So this is a small simulation which I wanted to show so that it becomes clear to you that how actually these things are working, right? Beautiful. Now, I have one more simulation for you guys, which is based on UDS. So as I explained a brief about how UDS works, I wanted to show that how the logs will be looking like. Okay, beautiful. So now, again, we have this localhost. Mhm. Same functionality. So let's say that in this scenario, there was any diagnostic issue or diagnostic information. So it just sends the diagnostic session. Or else, if there was any firmware download via OTA, it just reports as the firmware download. So if you can see in the logs, the first one was the diagnostic session request. So diagnostic session request is basically that it will be capturing all the diagnostic, how the car is currently in the state of, is it very heated? Is it running good? The tire pressures are good or not? So all that things on the surface level. Inside the car, there are more functionalities and diagnostic issues as well, which are to be focused. But yeah, let's focus on the surface level first, right? So this was the frame ID, as I told, arbitration ID, and this was the data, which was broadcasted to all the ECUs, right? And now the UDS service just identifies with the arbitration ID that, okay, this was a diagnostic session control. Henceforth, this is what we have to perform. This is what the car has to perform. And similarly, on the other hand, The frame ID for this was different, where it was leading to firmware download request. So via these frame IDs and the data which is being provided, the UDS actually identifies what kind of request is it, asking for, what is the car asking for, and then it performs the action, right? If you want to see a few other ones, you can see, right, the input-output control, the locking and unlocking the door, right? It's an input-output control, right? So the UDS service identifies this from this frame ID as, yeah, this is an input-output control frame ID, right? So this is nothing but the arbitration ID. Over here, I have not mentioned the same arbitration ID which I mentioned previously in the responses, but yeah, this is the same thing. Okay. And for different these responses, they have specific arbitration IDs. Perfect. I think I hope I was clear with a few things and few, in-depth analysis of how CAN works, UDS works, as well as the OT update works. I would like to get a shorthand review of how the session is going. Everyone active, right? Just drop a just drop the comment in the comment section or the chat box. How's it going, guys? All right, beautiful. All right. Thank you so much for your response, guys. Thank you so much. Okay, I think we are halfway through. Perfect. Now let's actually we have seen this. Yeah. Now let's move forward with other parts. So as I told, what if this trust breaks? The OTA, which uses the signing algorithms, which I explained via the API, all of this request goes through a encrypted channel. What if this encrypted channel is broken, as we saw in the Mercedes example? It would be a bit riskier for every car organization, right? So over here, I just explained. I am trying to explain with a small meme that if people think that RSA cannot be broke is not broken, it's actually broken. It was already broken because of certain algorithms which are used in quantum cryptography, right? So yeah, these all things can lead to a very, you know, uh, big impact on security perspectives and lead all the different vehicles on road in danger, right? So now there are other functionalities as well which can also come under this OT update and encryption part, which are also in under ledger called B2B communication, B2I communication, and B2X communication. Let's understand a small brief and move forward. B2B is vehicle to vehicle communication, where the vehicle with the other vehicle, vehicle A and vehicle B, try to communicate with each other via the wireless communication networking or the language they have to speak with, so that in case of any emergency, they can have a track and through which these network of vehicles can command and control can send requests to the command and control in case of any emergencies. Similarly, V2X communication is vehicle to everything communication. Henceforth, this is the vehicle and everything around which is connected to the internet. It helps to connect the car, right? It becomes very easy for a car to get the access of different devices around it, right? So all of that also comes into a risk factor. Now comes the most important question: how are we going to do it? Okay. So yes, ladies and gentlemen, the questions which you guys had, that how automotive security and quantum threat can be combined. Yes. So let's move forward and understand how quantum can help. So yeah, as I was mentioning you that RSA is already broken via the quantum algorithms. How is it? If no one from the quantum background, I would just like to mention that there is an algorithm called Shaw's algorithm, which can easily break RSA, which is multiplication of two prime numbers, right? Two large prime numbers in few seconds. So what if I say you that the first layer, because the encryption and the verification part never happens in one layer. It is combination of multiple layers like RSA. Then there will be a layer of hashing for verification, and there will be another layer which is protecting all of it. But what if one layer is broken? Still, it's a threat, right? So that's how this leads to automotive drawbacks, and hence it can lead to breaking in firmware updates. It can lead, uh, you know, insecure communication via V2X communication, a lot of things, right? Yeah, let's actually move forward and see why quantum cryptography now matters for vehicles. Okay, so for a fact, vehicles do have long life cycles. They can easily run from 10 to 15 years, right? So now, but the point is, in between that first year and 15th year, is your car secure, right? That's a big question. So now, ensuring that specific scope or niche in cryptographical area of how the things are working, how the updates will be happening, how the communication and protocols will be working, quantum cryptography plays an important role, right? So if you guys might have heard about harvest now, decrypt later functionality, or a statement which is so wild all around that people say that we should harvest now, in the algorithms or in strengthening the system, so that in future, even after 5 to 10 years, if some system getting is under attack, the attacker can not attack, and hence the system remains inactive, right? So it is able to respond for both the classical as well as the quantum threats which are emerging. That's why I've mentioned a small graph over here to explain you that, okay, let's say till 2040, there are quantum algorithms or quantum computers, big computers, which are present to, just play around with your cars, attack your cars. So within that life cycle, if your car is not secure and secure enough to protect you from these kind of attacks, even the classical or the quantum, and it would be a major threat to the automotive industry, right? So that's why these cars which are built today, which are on road, should also be protected through these quantum threats as well, right? So just providing a small brief of how the things I have mentioned in three boxes, but what is the threat, what is the constraint, and what response can we take, right, in securing. So first is threat, obviously, as I told, the algorithms like RSA, ECC are already broken by the quantum algorithm. So henceforth, it makes the timeline a bit short that these communication channels like V2X, V2E, as I explained, and the OT updates can be very soon under attack. And hence, yeah, the last ride. Right. Next is the constraint that, as I explained, the cars can have 10 to 15 max year of life cycle, 20 years for very high-end cars, right? These cars do follow a very old architecture of network, very old architecture of designing, which becomes difficult to update. And henceforth, with the upcoming cars, complex architectures will also, get updated. So this becomes one other constraint. Now, how we can actually provide updates? We can try to help out in securing the cars or the vehicles via the quantum future or the quantum technologies. So these are few points. First is secure boot. So secure boot is when your vehicle starts, everything like secure boot. If you use a laptop, there is a secure boot functionality through which your laptop or the system turns on, right, with the booting process. So similarly, vehicles also follow a very same functionality, which should be agile cryptographically as well. Second is the hardware security modules. Hardware security modules are basically which store all the keys, as I explained, a master key, which is being used for verification, right? In OT updates. Hardware security modules are one of the important components which help you to, just secure all the keys in a physical format, in a uh, physical hardware device. Okay. Next come is IDS. Okay. IDS intrusion detection system is something which every vehicle has, so that in case of any miss happening, the organization can easily go back, see what the logs were, what happened, what went wrong in the car, and then they can take the further action, right, in their future updates or future cars, right? So this thing is also very important, so that if and else an attacker tries to, just gather around the logs of intrusion detection system, which is in vehicle, he or she can get to know that what problems the car is facing and pinpoint easily to what part is to be attacked, right? Henceforth, we need a very agile post-quantum migration roadmap, which can include a lot of algorithms. And give an example, there are certain algorithms called Kyber 768 and Dilithium, which can be used for signing and key exchange, henceforth making the system a bit robust than the previous one. So yeah, we are in the end of the slide, ladies and gentlemen. And these are the key lessons which I would like to provide is that modern vehicles are not just four wheels which are being controlled by a steering wheel, but yeah, it's a full computer system running on road with a distributed networks. And attack surfaces cannot just be there in cloud or wireless systems, but also in the vehicle being a Bluetooth or internal networks. Right. Next is Canvas. So yeah, Canvas is obviously a most the important part of the vehicle, but there are certain things, there are certain shift in the industry where they are moving from CAN to flex rails, to flex buses as well, right? In the recent Tesla cars, this shift has been happening. Second is remote attacks, as I told, as we saw a few examples of Mercedes as well as the Jeep Cherokee attack. These remote attacks lead and just endanger the life of people, making us aware that okay, what things can be done to secure it. And last but not least is that the long vehicle lifetime makes it important to understand that the cryptographical part, the security part is also the automotive industry should look onto as well, right? So this is it, everyone. Now I would like for everyone to just give their awesome questions, and I'm really open to any question. Okay, I already have few. V2X, other way is giving vehicle cooperative awareness in law IoT environment, like definitely. Why is it that I'm 80% sure text below 15 equal to 3x5? Okay, tell me one simple thing. In large numbers, okay, this is a very small example, right? 15 is equal to 3x5. But in a classical computer, you take a bigger number. Taking an example, 655354142 something, right? And into some other number, some other prime number. Are you sure that a classical computer can, just easily multiply it in few seconds? Okay, this is a very small number which I've presented. But if it's a very, very, very big prime number, what do you say? A classical computer can easily multiply it in few seconds mathematically. No, right? I mean, although the computers do have a lot of performance evaluations and everything to just produce such bigger outputs. But the point is, it's that the quantum computers, the Shor's algorithm especially, they are not very, very, accurate with the results. Being it that, let's say the number which I portrayed you. Okay. So what if the number can be plus one, minus one, some way or the other? Because quantum computers work on qubits, which is either zero qubit and one qubit in different bases, which we are not getting into depth of. But just it just works on probabilities, right? It guesses the number and tries to get somewhere or the near to the prime number which was actually being multiplied so that it can be easily cracked, right? So that's what the reason is that I am 80% sure that yeah, 15 is equal to 3 into 5. Okay, how did you simulate the car environment in your system? Is there any GitHub repo available? Okay, currently the GitHub repo is not available though, but if you want, I can just publish it on my GitHub repo and just formulate it. You can check it out on, I think it would be out, let's say, you can just check out my GitHub. I'll be uploading after the session ends. So this is my GitHub handle. I'll just open it. Yeah, this is my GitHub handle. You can go. ECU simulator is already available. Also, if you want to try, you can try this. But it's more on CLI. Well, so the simulation which you saw in this presentation, in this workshop, it will be uploaded after this session. Yeah, question page. Yeah, any other question? Okay, there are. Nice session. Please tell how the car identified. Okay, okay. Nagaranjan has series of questions. That's nice. Okay, please tell how the target car identify X based on IPv6, or else, since it was connected to the cloud, there will be security to avoid. Yeah, okay. First of all, that the cars do work on a specific way of communication, right? They do not work on private IPs on IPv6 because see, most of the communication happens on the physical basis, right? As the car systems are working under the physical parameters inside a car, all the communication is being happening. But moreover, focuses on how the MAC addresses and everything will be focused, right? Will be communicated. So this is first point. Secondly, is that how that the security perspective, which you asked, that there will be certain amount of security being provided. But the point is that the security which is currently present cannot handle the quantum attacks, right? So, which means that even if there are classical algorithms available to detect that, okay, there is an OTA failure. Okay, that's a detection process. But the point is, while this scenario is being happening, that thing is already broken by the quantum threats, right? So this creates a very big loophole in the security perspective, right? And best practices to avoid this type of attack, this type of target is basically, see, right now we are on surge of shifting our classical cryptography to not pure quantum cryptography, but some way or the other, the hybrid balance of it, right? So this thing can help out, just to secure part of it, a layer of it, with the future quantum attacks, right? So I hope really, Nagarajan sir, that I answered your questions. Mayur, are there any try hack me like platforms to learn about automotive security? No. Well, I will be really very honest, brother. This is all about how you learn with the simulators. I will actually drop down few resources for you guys that would be really helpful for you. I am also using these same things. Just give me a second. I think one is Vayaka, which is a very famous tool. Vahaka, yes, Vahaka. This is a very famous simulator which can help you out to actually understand how the functionality is working, right? So this is by AminaSec Labs, and they are performing a beautiful, research on automotive security. Well, it's just easy. Follow the steps, you will be able to get it. And as well as there are a few tutorials available online. Other than that, if you want to actually practice just the dashboard part of it, you can also go with IC Sim. which is another bomb which can help you out to understand how the dashboard is working in a vehicle. So you can play with the indicators, you can play with the speedometer and everything. So it would be really interesting, and every step is mentioned. And more than Vahaka, tutorials of ICSIM are also available. So just go through it. And plus, if you want to learn via some paid sources, you can go on Udemy. There are a lot of basic CAN-based attacks, CAN fuzzing-based attacks, resources and videos available. So you can also refer that as well. Okay. I hope I answered your question. Hi, Daksh, are there any skills should student focus on if they want to work in automotive cybersecurity? Okay. See, man, understanding first the basics of how an automotive vehicle works, along with, yeah, thank you, sir, Guru sir, and sir, that the Craig Smith book, Car Hacker's Handbook, is something which will build it. That will help along with how you work with the simulators, how the CAN network is working. Because see, the ECUs and components, that is something hardware will be providing. But understanding how the simulation and the software part of it is working, you can get into it, right, with the help of these simulators. So you can use that resources, as well as can you suggest some resources to understand post-quantum cryptography? Surely. See, post-quantum cryptography, there are not much simulators, but if you want to understand the cryptographical and mathematical part, uh, you can directly refer to either, there are certain videos on NPTEL. Well, that would be the mathematical part to build your base. And other than that, there is a book on post-quantum cryptography. I'm forgetting the name. Yeah, this one. This one you can actually refer. I was reading this by William Jenkins. This is a very great resource to understand, the security perspective of how you can integrate with different fields as well. This is one good to go. And okay, I hope I have answered your question. Next is, Daksh, it was really great session and quite insightful. Do you think AI will play a major role in detecting and preventing attacks in connected vehicles? That's a very beautiful question, Deepika. Uh, I believe that AI can definitely help in predicting the things while detecting the attacks, right? So I think, yeah, AI will also play a major role in detecting pre-detection of these attacks, which can help in future to prevent these kind of attacks, right? But I believe with the security perspective, if we see, then to the quantum, not the quantum, but the cryptographical robustness is still needed, right? So yeah, that's my view over it. I hope I answered your question. Okay. Deepak, I want to understand the software architecture of car and all the protocols. From where can I get it? As Guru Saran sir mentioned it, you can refer the Cars Hackers Handbook. Okay, it will give you the hacking perspective, the security perspective of it. But if you want to understand the software architecture, you can refer YouTube videos, because that's I served a lot while researching on it. That how the infotainment systems is getting connected, how is it working and everything. So and how the canvas is working, how ECUs are responding via canvas to the gateways, etc. You can refer some specific points of it one by one, and then I think it would be good to go to understand how protocols are working and how the architecture is working. I hope I've answered your question. Thank you so much, Akshat. Thank you so much. It really means a lot that I'm able to deliver some part of my research over automotive security to such a great crowd. Thank you so much. Any other questions?
Team, everyone, we will hear for your questions for another 2 or 3 minutes. Please ask your questions right away. After that, we will start generating the certificates for everyone.
Thank you so much, sir. Thank you so much. It means a lot.
Daksh, we have one question from
Yeah.
Guru Saran actually,
Oh, yeah. Just so.
and
Any?
also one more question that was requested in the initial timing of the session. I will
Yeah,
check out with
I
that.
did answer it, I think, in the between of the network part. Yeah, I did answer that.
Whether okay, whether I just remembered whether all canvas is similar to every cars. That was the question.
Oh, right. Where they connected and sniff the canvas. Oh, my bad. The network architecture one, right? If I'm not wrong. Any recommendations for ECU simulator? Um, I believe that if you want to build your own ECU simulator, first understand, the basics of how the CAN bus is working and, how the CAN see, because as I said, that there's a bits and pieces of information which is being transferred from one part to other. So you should first understand that how that functionality is working. Then I think it would be good to go because there are in Python you can easily build your own simulator via CAN, Python CAN, PyCAN interfaces, libraries, right? So yeah, I think it would be easier to go first with the basics and then develop your own simulator in Python. You can also refer my issue simulator. It's CLI based right now, but the other one which I will be uploading, which I showed in the presentation, that will be uploading right straight away. And sir, I think and the other question was any insights on SDV? Uh, SDV, can you elaborate about what SDV, the full form of it? Okay, software defined vehicles. Right. Okay. Perfect. Because I'm not very familiar to the term. Yeah, but software defined vehicles, you mean basically the one which are being controlled via mobile phones and the interfaces inside the car, if I'm not wrong, right? Yeah. So my insights are that these systems would, right now the systems are very open to these calls, as I explained the API calls. Right? So I just believe that in order to increase the security of it, we can, okay, API is something which will remain constant, but we can include some or the other way in the request itself for increasing the authorization of it and authentication part of it, so that the attacks which are happening, as the remote access control attack happened, right, in Mercedes, these things do not repeat, right? And another perspective which we can see inside the vehicle, which is the infotainment systems, I believe there is no option to just modify the flex bus part or the CAN bus part, which is connecting to the infotainment system. But what we can try to do is just the communication part between infotainment system and cloud can be secured. Right. So that's what I believe would be more feasible rather than changing the whole system, because I don't think that any car organization or OEMs would like to change their hardware architecture. Right. So, yeah, that's my views, I believe. Thank you so much.
Any more questions, everyone? Do we have any more questions? Great. I'm presuming that we don't have any more questions. So, Daksh, really appreciate your time for taking such a wonderful session. It was really wonderful. A lot of insights. You shared quite a lot of information about even when, covering the practical aspects of it. Me, myself into cybersecurity, specifically OffSec part, the automobile industry is something not pretty wide open, but still you took your time to show us the huge information, share us the huge information about the automotive industry. Really appreciate it. Thank you.
Thank you so much, Avinash, for
Yeah,
inviting me to such a prestigious stage. Thank you so much.
wonderful. Thank you. So the next is for the participants, whoever has attended this session. So we require everyone to submit a feedback form. Your feedback is most valuable for us. This will help us to improve our uh, upcoming sessions. We have quite a lot of sessions planned. Even this month, next week, we have one of our offline session happening in one of the corporate events. So it is all available in the Owasp website as well as in our WhatsApp group. All details are available, and we have already sent out the invitation, confirmation invitation. Whoever has received the invitation can attend the session. We have tried our best to accommodate as much as possible, but some people we were not able to accommodate because of the seat limitations. So we will try to arrange more offline sessions. Please keep updating yourself using our WhatsApp channel, WhatsApp website, as well as our LinkedIn page. Now, please submit your feedback. Once you submit your feedback, everyone can download their certificates instantly in less than 20-30 seconds hardly. It will be auto-generated and you can download it using the same QR code, or in the response itself, you will find the link for downloading your e-certificates. I'll keep this page for like another 1 or 2 minutes. In the meantime, if you have any other questions, please uh, feel free to ask. And I'm also dropping the link for the session in the chat. I believe the QR code is visible, right, Daksh? Just wanted to confirm.
Yeah, it's totally clear.
Perfect. Okay. So if you find any issues with the certificate, let's say, for example, due to automation, sometimes if your name is too long, you might feel something fuzzy happening. So if you find anything with the certificates, please reach out to this DL, Coimbatore leaders at owasp.org. I will paste that as well in the chat, just in case. So this is our distribution list where our leaders are there. So if one person is not available, the other will definitely respond. So feel free to reach out for any sort of queries related to Owasp Coimbatore sessions or events. So I believe there is no more questions. So I appreciate again Daksh to taking the time for the session, and we are really thankful for a wonderful, insightful session, and definitely for other participants as well. If anyone is interested to take an interesting session, you have a wonderful topic to share it to the community. We are always welcoming new participants, new presentations, new topics, new ideas, everything. We are of course an open source community. So if anyone is volunteering to take a presentation on our session, offline as well as online, we'll be more than happy to accept your presentations. You can also drop your interest in our DL, or we have a separate speaker registration form in our Owasp website. You can find it over there. All right then. Thank you everyone for joining the session. Thank you, Daksh. Appreciate it.
Thank you so much, everyone, for joining this evening. And you have been such a wonderful crowd. Thank you so much for joining. Signing out, Daksh Bhagwani.
Thank you everyone. Bye bye.